Hello class, and welcome to the first part of section 5.5, which is about solving multi-step equations. By the end of today's lesson, you will be able to solve multi-step equations. So when we are solving multi-step equations, we want to continue to follow our steps for solving. So we want to get rid of these parentheses first. So in this case, it's just a negative sign or a -1 that is outside the parentheses. So when we distribute that, I'm going to get 12 is equal to -1x, and then -1 times 2 is -2. Then I have a regular equation that I can solve, so I look to eliminate adding or subtracting first. So I'm going to get rid of subtracting 2 by adding 2 to both sides of the equation, and I've got 14 is equal to -1x. And then I need to get rid of that coefficient, so I'm going to go ahead and divide both sides by -1. And I'm going to get an answer of -14 is equal to x. As with all equations, you could plug that back in to check your answer. -14 plus 2 is -12 times -1 gives you an answer of 12. So it checks out. One thing I want to point out is the difference between when an equation is set up like this, where the denominator is over the whole equation, and when a denominator is set up over part of the equation. If the denominator is under the entire equation, it needs to be eliminated first. We need to treat this like this top part is in parentheses, and we can't access anything up top until we get rid of the denominator. When it's written in this format, where the denominator is just underneath the variable, you would eliminate the 6 first because it is not trapped in the numerator part. So, given the problem that we had, we want to eliminate the 3 first from our equation. So we're going to do that by multiplying to get rid of the division, both sides of the equation, by 3. So when I multiply, that gets rid of my denominator, and I have m minus 6 is equal to 51. Then I can just go ahead and get rid of my subtraction by adding on both sides, and I get an answer of m is equal to 57. Go ahead and try this one on your own. Distributing on both sides, the first one distributing the 3, the second one distributing that negative sign, combining some like terms over here on the right side, moving the x from one side to another, moving the number back to the other side, and then solving, we get x is equal to -39. Another example here, we're going to go ahead and distribute on both sides to start. On the left side, I end up with 4x plus 20 is equal to the right side 4x plus 8. We want to get our variables together now, so I'm going to go ahead and subtract 4x from both sides of the equation. And you'll notice when that happens, the variables on both sides are eliminated. And I am left with a statement that says 20 is equal to 8. So basically what this is telling me is that no matter what we plug in, this equation is going to get us down to an answer of 20 is equal to 8. We all know that that is not an actual thing that can happen. 20 of something is not the same as 8 of something. So if you end up with an equation like this, where you have two non-equivalent numbers set equal to each other, the answer is going to be no solution. It means that no number that you plug in for your variable can actually make this equation work. On the flip side of that, if I distribute this equation now, I'm going to end up with 3y minus 15 plus 25 is equal to 3y plus 10. Looking on that left side, I can combine -15 with a positive 25, and I end up with 3y plus 10 is equal to 3y plus 10. Now, this time, when I eliminate my variable by subtracting 3y from both sides, I get a different sort of statement. This time, it says 10 equals 10. So no matter what we plug in for y in this case, it's always going to boil down to 10 is equal to 10. What that means is that there is infinitely many solutions to this problem. AKA, you can plug any number into this equation, no matter how big or small, whether it's positive or negative, and you will get an answer that simplifies down to 10 is equal to 10. So no matter what you plug in, it will always filter down to 10 is equal to 10. And that is how we get infinitely many solutions. Go ahead and try this one on your own. So when you distribute, simplify by moving that variable over, we end up with 14 is equal to 32. So this is a no solution example. Last one, we've got our word problem. Mariella's parents have budgeted $575 for her quinceañera. The cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receives a $5 favor? So there's a lot going on in this problem. The first thing is that they have budgeted $575. That means when all is said and done, the cost is going to equal $575. Then it says they also have to pay for the party room, which we know is going to be $75. They also are going to do two things per guest. They're going to buy them food. That's the piece we don't know. And they are also going to give them a $5 favor. So the x plus 5 happens for each person, so that's when we put it in parentheses and say that there are 40 people. So this is the cost for each of the 40 people plus the party room, and that has to equal our total. Go ahead and solve the rest of this one on your own. As you finish solving this equation, you're going to distribute, combine those like terms, and then solve like a regular equation to find out that it is $7.50 per person. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.